Let's look at a couple of examples to illustrate what to look for. All right, number one. Suppose I gave you this system here. And we want to solve this, not by substitution, which this would not be difficult to do by substitution, by using the addition method. Again, the idea is, if you start with an equation, and you add things of equal value to both sides of the equation, what you end up with is another equation that is valid. So we're going to add these two equations. Now, before I do it, can someone remind me why we may want to do that? What do we hope to accomplish by adding these two equations? For the y, the variable y to cancel out. 5x, the y's cancel out, equals 10. And now we end up with a one-step equation that we can solve easily for x, right? We added the two equations, the y's cancel in the process, and now we're going to say right here, divide by 5 both sides of the equation. 5 divided by 5 is 1. We have 1x equals 2. Now the addition method is often used in combination with the substitution method. So now that I have the value of x, what I'm going to do is I'm going to substitute this value into one of the two equations. Which one?
Anyone.
It makes no difference. It is the same x value for both equations, and if we've done this correctly, it should yield the same y value no matter which one we use. I'm going to substitute in the top one here. I'm going to take x and plug it right in here. So I have 2 times 2 is 4 plus y equals 8. How do I solve for y?
Minus 4.
Minus 4. So now that I have found the x and the y value, I can express a solution to the system as an ordered pair. Meaning, well, what is the ordered pair? What's 2 comma 4? Can someone tell me with a simple sentence what this point represents? What is that point? Yes. The point of intersection of what?
Of the 2 lines.
That's right. If you were to graph these 2 lines, we didn't, but if we were to do it, where would they meet? At what point?
At 2, 4.
At the point 2, 4. This is the one point that lies in both lines, meaning that it is a solution to both equations. Does anyone remember what we call a system that has one solution?
Yes,
What is
consistent.
consistent. This is a consistent system.